For all ages, science projects should follow the scientific method: question, hypothesis, materials or procedure, observations, data analysis or discussion, conclusion. The question stage is just that, the asking of a question, specifically a testable and quantifiably measurable question, so you can run an experiment in an attempt to answer it. For example, what kind of popcorn pops the best? Kettle corn or butter popcorn? Once you have a question, you can form a hypothesis. A hypothesis is an educated guess. You should explain what you think will happen and why you think it will happen. For example, if the butter in the popcorn bag interferes with the heat getting to the kernel, then I believe that the kettle corn will pop the most efficiently because it only has oil in the bag, while the butter popcorn has oil and butter. Your hypothesis, like your question, should be testable and quantifiably measurable. Researching your question may help you to form such a hypothesis. When you prepare for your experiment, you need to keep track of all the materials you're using and how much or many of each you use. When you present your project, this will allow others to exactly replicate your experiment. It'll also help you in identifying variables. The next step is to perform the experiment and record the procedure you follow. The more detailed the record or procedure, the easier it will be for others to repeat your experiment and tweak it to answer other questions. The observation step happens concurrently with the procedure step. As you go through your experiment, you should objectively record your observations. Once the experiment is finished, you should record your experiment results in an organized manner, such as through the use of charts, graphs, or tables. A midpoint between the observation and conclusion stages is the data analysis or discussion stage. This is where you interpret the results through logical discussion. You should use the data that you collected in your experiment, along with any facts that you previously knew, in order to explain why you came to your end results. The final step is the conclusion. The conclusion is where you combine all of your efforts in order to answer your original question. Your conclusion should draw off of your observations. Here are some extra tips. 1. Make sure you include many relevant pictures of the experiment and visuals representing the results. 2. Keep your project neat. All sections should be labeled, pictures should be captioned, and everything should be in a logical, followable order. 3. Make sure you are only testing one variable. Everything else should be controlled. 4. Run through your experiment multiple times, recording the results each time so that you can confirm the validity of your conclusion. And 5. Do something different. Volcanoes are fun, but you already know what's going to happen with a volcano project, don't you? Challenge yourself. Brainstorm a variety of unique questions before you choose which one you want to answer.